All right, so I have this matrix here and I'm supposed to find the inverse. So what I'm going to do is I'm going to use the Gauss-Jordan elimination method and then together with the Gaussian elimination method to find the inverse here. To do this, you're going to utilize the identity matrix and also this matrix here. So how you go about this is you put these two in an augmented matrix. Okay, so we know the identity matrix for a 3 by 3 matrix, that is I3, which is equal to 1 0 0 0 1 0 and then 0 0 1. Right, so these two matrices, I'm going to put them in an augmented matrix and then perform my normal Gauss-Jordan elimination method. And if you remember, we have a lesson on that, which you're going to use two way of row operation. First you do for coming down, and then the second part is you do backwards. I mean, you do from bottom to the upward. So what you're going to do is I write my matrix A as 1 2 3 and then 2 5 3 1 0 8, and then I put a line. If you want, you can do that, but that depends on what you want to do. I'm going to use a line, a straight line, to divide the A and then the identity matrix. So with the identity matrix, I have 1 0 0 0 1 0 and then 0 0 1. And if A is invertible, you're going to get something nice. Okay. So what I'm going to do is that I'm basing on this matrix for A on the left side of augmented matrix and perform my normal row operation on it. Okay. So what I'm going to do is that I'm going to transform my row 2, row 3 into something. So first, if you multiply -2 to row 1 and add it to row 2, that's going to make sure that the 2 tends to 0. And then if I multiply -1 to row 1 and then add it to row 3, that will also tend to 0. So we will have our first matrix, or the first transformation, to be 1 2 3, and then on the other hand I still have 1 0 0, and below the 1 I have 0 here, and then -2 times 2 is -4 plus 5 is 1, -2 times 3 -6 plus 3 is -3, and then on the other hand -2 times 1 is, so I'm on this one, it's -2 plus 0 is -2, and then -2 times 0 is 0 plus 1 is still 1, so I still have these there. Now on the last row, I'm going to get 0 here, and then -1 times 2 is -2 plus 0 is -2. That of that, -1 times 3 is -3 plus 8 is 5. -1 times 1 is -1 plus 0 is -1, and then I have these back. Okay, so that's our first transformation that we get for this operation. So now what we are supposed to do is continue with this and try to transform the rest of them. Okay, so I'm going to base on this one and make sure that the number below it, that is the -2, is also 0. And to do that, the transformation you're going to need is 2 times row 2 plus row 3, and that will give us a 0 there. So our new matrix here is going to look like 1 2 3, and I still have my 1 0 0 0 1 -3 -2 1 0. And then what we're going to do on the other hand is transform them to 0. So 2 times 1 is 2 plus -2 is 0, and then 2 times -3 is -6 plus 5 is -1, and then 2 times -2 is -4 plus -1 is actually -5. Okay, and then 2 times 1 is 2 plus 0 is what? 2, and then I have that. So I'm done with the first transformation, that is the Gaussian elimination. Now to complete with the Gauss-Jordan elimination, I'm supposed to start reducing the same matrix that I did starting from the bottom here all the way to the top. Okay. So, but before that, I can try to also make sure that this value I have here is positive 1. And then to do that, I have to just multiply negative 1 through row 3. And that will give me a new row 3. Okay. So, if I do that, I have my new augmented matrix to be 1, 2, 3, 1, 0, 0, 0, 1, negative 3, negative 2, 1, 0, 0, 0, then positive 1, positive 5, negative 2, negative 1, because I multiply negative through the whole of them. Now, I want to perform this row operation on from the bottom to the up there. Okay, so starting from this guy. So every number below it or above it, okay, so that is from the bottom to the upward. So every number above it should be 0. And what I'm going to do is to transform the new row 2 or my row 2 to something else. So 3 times row 3 plus row 2 will give me that 0 there. And then that should give us our new row 2. And then the other transformation will be negative 3 times row 3 plus row 1. That should give us a new row 1. Right? And this transformation here is going to be, or it's going to give us 1, 2, let me write from the bottom first. So 0, 0, 1, and then 5, negative 2, negative 1. What I'm going to do to the top is multiply 3 to row 3 and then add it to row 2. And that's going to give me 0 here at this part. And then 3 times 0 is still 0 plus 1 is 1. And then this will also give me 0. Now, negative 3 times row 3, that will give me negative 3 here, plus 3 is going to be 0. And then negative 3 times 0 plus 2 is still 2. And then negative 3 times 0 plus 1 is still 1. Right. Now you go to the other side. Between these two, it is 3 times row 3 plus row 2. So 3 times 5 is 15 plus negative 2 is actually 13, I think. Yeah. And then the other side is 3 times negative 2, which is negative 6, plus 1, and that's going to be negative 5. Now 3 times negative 1, which is negative 3, plus 0, and that is going to be negative 3. Now between the third row and then the row 1, it is negative 3 times row 3 plus row 1. So negative 3 times 5 is negative 15 plus 1 is negative 14. And then negative 3 times negative 2 is 6 plus 0 is 6. And negative 3 times negative 1 is, 3 plus 0 is 3. So I have this. Now the other side is that I'm supposed to also make sure that this value above this 1 is also 0. So that's the last operation you are supposed to perform. And with that, what you can do is negative 2 times row 2, then plus row 1. And that should just end everything for us, okay? So if I continue with this, I'm going to get a transformed augmented matrix, which is going to be 1, and then let me start with the last one, 0, 0, 1, and then I'm going to have 5, negative 2, negative 1, and I'm going to have 0, 1, 0, 13 here, negative 5, negative 3. So the last one is going to transform to, or the row 1 is going to transform to, like I said, negative 2 times row 2. And so negative 2 times 0 plus 0 is still 0. So that part is still 0 here. Negative 2 times 1 is negative 2 plus 2 is 0. I'm going to have 0 here. Negative 2 times 0 is 0 plus 1 is 1. So I have the identity matrix on the other side. And then when you come to this right side of the augmented matrix, what I did was negative 2 times row 2, right? So negative 2 times 13 is negative 26, plus negative 14 is negative 40, and then negative 2 times negative 5 is 10, and then when you add it to 6, you're going to get 16, and then negative 2 times negative 3 is 6, plus 3 is 9. Okay. So what we've done here is to actually transform or interchange the augmented position. So at first we had A and then the identity matrix, and now we've been able to transform it into the identity matrix here and then something here. Okay, and that something I have is the whole thing, or the whole matrix I have on the right side, and that becomes our A inverse, or the inverse of the matrix. So A inverse is actually equal to that last part, which is negative 40, 16, 9, 13, negative 5, negative 3, 5, negative 2, negative 1, and that gives us our inverse of the matrix given. Okay, so that is one way of finding the inverse of a matrix. And if you want to really confirm this is true or not, you can try to multiply them. You can try to multiply A and then A inverse and see if you get the identity matrix, but I assure you that you're going to get the identity matrix. Okay, so see you in our next lesson, and then don't forget to subscribe to my channel.